Hello, this is my presentation for Physics 2212's Lab 2 Lines of Charge. The purpose of this lab was to produce a computational model of two charge tapes exerting an electric force on each other, and use this model to estimate the amount of charge on each tape necessary to float one above the other. An overview of the results is that the estimated Q on a piece of charge tape is 4.63 times 10 to the negative 8 coulombs. We use three fundamental principles. Newton's second law for gravity, which states mass times gravity equals force. Newton's third law that states for every force there's an equal and opposite force when there's no acceleration occurring in a system. And finally, Coulomb's law, more specifically the principle of superposition and the distribution of charge along a line. Some assumptions we made are that air resistance is negligible and that there is no acceleration occurring in the system. Unlike the last lab, we are evenly distributing the charge of the tape along the surface rather than the charge being concentrated at one point. From the previous lab, we gathered these measurements to help drive our model today. Using these numbers and calculations, we assume our charge of the top tape to be 2.64 times 10 to the negative 8 coulombs, which we will use to build our model. Here is the link for the glow script code I have built for this lab. First, looking at this done last time, we see our tapes modeled as points. Charge was evenly distributed, but at a singular point, and balance between forces was easier to maintain. Moving on to today's purpose, our biggest difference in modeling was to depict our tapes as lines rather than points. Along the top line, aka top tape, we need to distribute little point charges across the surface. This is done by breaking the top tape into individual pieces, creating little point charges. The more pieces, the more accurately the force is depicted, since electric fields along a line are created by every individual charge within the surface adding together. Here we have our code being run with the charge used from Lab 1. All those green arrows add together to get the white arrow, which is our force produced by the electrons. However, we see that my electrical force and my gravitational force are not equal. Because of this, we know that the charge we acquired in Lab 1 is inaccurate and an underestimate. Playing around with the Q value in my code, we find a more accurate read for Q to be 4.63 times 10 to the negative 8 coulombs. When our Q equals this, then our force magnitudes are more similar, meaning the system is in a state of no acceleration. The top tape floating above the bottom tape. A question to ask is, what if we had modeled each of our tapes as a singular point charge like in the previous lab? Like I said, if we had used point charges, our charge value would be a severe underestimate. Why do these estimates differ, and which value is more likely to be closer to the real value? The larger value is more likely to be more accurate because the objects like tape do not concentrate all of their charges in a singular spot. Electric charge is spread over a surface like modeled in Lab 2. Therefore, Lab 2's model is more likely to be accurate since it follows real-life principles. Possible errors may have occurred from mishandling of tape, the negligence of air resistance, and inaccurately reading measurements of the tape dimensions or the distance between the top and bottom tapes.